start talking about proving that two triangles are congruent. Right? We're going to start talking about ways to prove that two triangles are congruent. These pairs of corresponding pieces are congruent, right? All three pairs of sides and all three pairs of angles. So technically, to prove that two triangles are congruent, we would have to prove that all 6 of those corresponding pairs are congruent. However, we have a few shortcuts. Okay? And these are the 5 shortcuts that we're going to look at over the next few sections. Okay, today, I don't know if we'll the goal is to get through the first 2, but we'll see how far we get here. Okay? If I can prove that all 3 pairs of sides are congruent, if I can put all 3 pairs of sides are congruent between 2 triangles, that's enough to state that the triangles are congruent. I don't have to say about the angles. Right? If I can just say, this side is congruent to this side is congruent to this side, and this side is congruent to this side, that is enough to say that the 2 triangles are congruent. Right? The other one that we're hopefully going to be able to get to today is side angle side. Right? If I can show that 2 pairs of sides and the angle that's in between them, is congruent, then I can say the 2 triangles are congruent. Okay, so for example, if I say this pair of sides is congruent, and this pair of sides is congruent, and the angle that is in between those 2 sides, if I can say those 2 angles are congruent, that is enough to state that these 2 triangles are exactly the same. Okay. Now we have a few other shortcuts that we'll look at in later sections. Okay? So this sheet is important, okay, for you to hold on to, keep track of, because this is going to be our reference sheet, okay, our cheat sheet, if you will, for the next few sections. No, we're going to come back to the rest of those in the next section. All right, so down at the bottom of this reference sheet, though, okay, it gives us, well, yeah, but before we get there, okay, it gives us a list up here of possible common reasons that we could have sides be congruent or angles be congruent. Okay, and we're going to look at these as we go through some examples of proofs here. Okay, but that's why this reference sheet is going to be super important. Okay, this is going to help us determine possible reasons to show that sides are congruent to each other. Or that angles are congruent to each other. Okay? So, and then this CPCTC thing is another idea that we're going to come back to in a later section. Okay? So, these are all reasons that we've already talked about. Okay? We looked at all of these reasons back in chapter 2 when we did segment and angle proofs. Okay? We're going to use them again to talk about. What's that? Well, we're going to do some more proofs here. I promise you, though, that these proofs are easier than the ones that we did in chapter 2.
I like that.
Yeah. Okay. So, if we look at our list of common reasons here, okay, we're definitely going to have some information that's given to us. Remember, if we're told that something is a midpoint, that automatically creates 2 congruent sides. Okay? For example, if I know that if I've got some line, right, and I'm told that B is the midpoint of AC, that automatically tells me that AB and BC are congruent. Okay? The reflexive property is one that we talked about, but we didn't really use a lot back in chapter 2. This one is going to be super, super common when we're talking about triangle proofs. Okay? The reflexive property is the one that just says something's congruent to itself. Okay? Something is congruent to itself. So, if I've got 2 triangles that have an overlapping side, right? If I've got 2 triangles like this that share a side in the middle, I can just say, well, that side's congruent to itself. And that one is going to end up being pretty common. And then when we're talking about angles, okay, one that is also going to be pretty common that we didn't use a whole lot before is vertical angles. Okay, and remember, vertical angles are formed whenever I have a pair of intersecting lines. Guys, come on. Vertical angles are angles that are across from each other when I have a pair of intersecting lines, and we know that those are congruent to each other. These three here, right, alternate interior, alternate exterior, and corresponding, we can only use those if we have parallel lines. And we'll look at examples of that here. Okay, but whenever we're given, we'd be thinking about alternate interior, alternate exterior, and corresponding. And then the last common one here is definition of an angle bisector. If I'm told that something is an angle bisector, then that tells me that those two smaller angles that are created would be congruent. So, for example, if I know that BD is a bisector of ABC, that automatically tells me that these two smaller angles are congruent. Okay, but for this one, we have to be told that something's an angle bisector. Just like up here, we have to be told that something is a midpoint. Okay? So we're going to skip the CPCTC stuff for now. We're going to come back to that later.
Say that one sentence. CPTC.
It's just 5 letters.
Without reading it though, like CPTCT.
CPCTC.
Yeah, all right. See? Are you done?
No. So, like I already mentioned, if I can show that all 3 pairs of sides of 2 triangles are congruent, then I can conclude that the 2 triangles are congruent. So here, in this picture, they tell me that AB and DE are congruent because they have the same number of marks on it. So I can say if I know that AB is congruent to DE, and also we know BC and EF are congruent because they have the same number of marks on them. BC is congruent to EF. Then also, I know that these 2 sides are congruent, AC and DF. So if all 3 of these things are true, all 3 pairs of sides, then I can claim that the 2 triangles are congruent. So then I could say triangle ABC is congruent to triangle DEF. Now, if you remember from yesterday, it does matter how we write this triangle congruency statement. Right? We just have to match up corresponding pieces. Right? So we said AB matches up with DE, BC matches up with EF, okay, and then AC matches up with DF. Okay, so there are other ways that we could have written that statement, just as long as we're correctly matching up corresponding pieces. Okay? So let's take a look at our first proof here. Okay, proving that 2 triangles are congruent. And so down here, I'm given a decent amount of information. Okay? So my goal is to prove that these 2 triangles are congruent. Okay, well, right off the bat, I'm given that PQ and ST are congruent. Now, we talked about this before, okay, but now it's going to be even more important to actually mark that information on the diagram. So if I'm given that PQ and ST are congruent, I want to mark that. I want to put the same number of dashes on those 2 lines on the diagram. Right? So in my proof, the reason for that is if. Okay. Well, then they also tell us that QR and RT are congruent. That's also given, yeah. Right? And we also want to make sure we mark that on the diagram. So I'm going to put a different number of tick marks on those 2 lines than I did on my first pair. Well, now definition of midpoint. You're jumping ahead. So the next one will be, but this one is still given to us, right? We're given that R is the midpoint of PS. But if we know that R is the midpoint of PS, then I can claim that these two halves of that segment are congruent by definition of midpoint. Right? If we're told that something is a midpoint, I can claim that the two halves of that segment that are created are congruent by definition of a midpoint. Okay? Well, now, if I look at my two triangles, I have these two sides congruent, these two sides congruent, and these two sides congruent. That is enough to claim that the two triangles are congruent. Once I've shown all three pairs of corresponding sides are congruent, I can say the triangles are congruent by side, side, side. Okay, we're just going to write that abbreviation or shortcut there, side, side, side. So our goal for these, for all of these in this first part, is to prove that all three pairs of sides are congruent. Questions so far?
Alright, so it's not going to tell us what it is right off the bat, though.
Tell you what is.
Like the side thing.
Eventually, no. But for right now, since that's the only one we've done so far, all of these examples are side, side, side. But yeah, it's not going to tell you which one to use. Okay. So why don't you guys see if you can do number 2 here. This one is going to be, and we're trying to prove that these two triangles are congruent. So let's take a minute here and see what you can do with number 2. You're right. That should actually be JK is congruent to NK. You're right. That is a small little mistake.
So it should be definitely congruent.
Well, so if we're told that K is the midpoint of JN, then I can say that JK and NK are congruent because that's the midpoint. So that would just be definition. No, definition of midpoint. Yeah. So if I'm told something's the midpoint, yeah, then I can say these two halves are congruent because it's the midpoint.
I kept thinking it was something that had to do with congruence.
That's what I kept thinking. That's why I sat here and stared at it.
We're actually, in these ones, we're really not going to use definition of congruence very much.
Can I have my teeth done? Just break them? I don't want you to break my teeth. Thank you. For number
Someone did
Oh, I think it's number 4 is the garage. That's my guess.
See that right here?
Does that get something like this for number 2? Okay, so we are given that JL and MN are congruent. And then I'm told that K is the midpoint of both JN and LM. So then, if I know K is the midpoint of both of those lines, I can claim, well, JK and NK are congruent because K is the midpoint, so that's definitely midpoint. And then I can also say that LK and MK are congruent because K is the midpoint. Right? That's just definitely midpoint. So now I've got all 3 pairs of sides congruent. I can say the triangles are congruent by side, side, side. Okay. Questions? All right, so let's take a look then at one that we have to write ourselves. Okay, we got to write the whole thing ourselves here. So we always start with the given information. Right? I'm given that AC and AD are congruent. So I'm going to mark that on the diagram. AC is congruent to AD. Then I'm given that CB and BD are congruent. Okay, so that's these 2 sides. So now I just have one more pair of sides to show congruent. So what's the last pair of sides for each of these triangles? AB, yeah, it's both of them. The last side is AB, right? So whenever 2 triangles overlap or share a side, we can say that side is congruent to itself. What property is the one that lets me say something is congruent to itself? Reflexive property, right? So I can say AB is congruent to AB by the reflexive property. So now, if I look at my diagram, okay, with all my, I've got. What doesn't make sense?
How is A congruent to AB?
How would it not be? That's like saying you're the same height as you. Yeah, because we're looking at this triangle has side AB.
I was looking at it as they were connected.
Well, they are connected.
Well, you know what I mean. I was thinking that as
Okay, yeah. So we're looking at these 2 triangles separately, and they share a side. Yep. So now I've got side, side, side in both triangles. So now I can say triangle ABC is congruent to triangle ABD. And remember, whatever we want to prove is what should be in the final line. And then my reason here is SSS. Right. Questions?
no, sir.
All right. No homework.